Greetings and welcome to InfoTrend. Today we will compare three main ways of replicating data between our systems. To choose the right replication method, it's important to first understand how our storage is structured. We'll begin with a quick look at the overall architecture and then review the different replication options one by one. Starting from the simplest and most cost-efficient approach, we will move up to more advanced solutions like active-active clustering, so you can see which method best fits your business needs. First, as you might already know, our GS systems are a true unified solution, meaning that they combine both SUN, block level, and NAS, file level possibilities. File level volumes use a file system managed by the storage itself, which enables a wide range of built-in features. For example, the system natively supports the Rsync protocol, which makes it easy to set up a folder-level replication between different sites for backups, or distribution or archiving. Beyond Rsync, our GS systems also provide two additional replication methods, remote replication and high availability or HA service, both of which can be applied to file and block level volumes. Together, these options give you multiple layers of data protection and availability depending on your specific business needs. The first method, Rsync, works on file-level volumes. Rsync is a protocol supported by the majority of modern systems. This technology has its limitations, in particular throughput, but it is a simple way to replicate your folders hosted on the GS system and does not require any paid licenses. So out of main advantages, we have a very simple setup. It supports both Linux and Windows machines, as well as any other Rsync capable target, runs on an adjustable schedule, and the traffic can be encrypted. Unfortunately, it also has some limitations. First of all, it can be used only for file level volumes, as already mentioned. Next, no option for creating a mirror replication. It does not preserve snapshots, and slower with large number of small files. And other than that, finally, no built-in failover recovery. Now, a real-life use case where Rsync was the most suitable replication option available. A company runs an InfoTrend GS system at its headquarters in the USA and another at its branch in France. With Rsync replication, project files and shared folders are automatically synchronized on a schedule, ensuring teams on both sides always work with up-to-date data. The marketing team can upload large media files such as videos and product photos to the primary GS system, while Rsync seamlessly distributes copies to the branch systems. This allows local staff to access the content instantly without repeatedly transferring large files over the WAN. For compliance and security, replication traffic can be encrypted to meet data protection regulations, while features like WARM safeguard information against malicious attacks or accidental deletions. The second option is remote replication. It is more advanced compared to Rsync. It offers higher throughput, allows to set up synchronous replication, works with both file and block level volumes, and supports both snapshots and failover. InfoTrend remote replication is exclusive to InfoTrend storage systems and requires the purchase of a license for each system that you are planning to include in a replication pair. Pairs can work as one-to-one, one-to-many, and many-to-one as well. Now, remote replication has several advantages to it. First of all, it's a block-level technology. It is faster and more efficient for large data sets. It can be scheduled for regular asynchronous replication or configured in a synchronous mode. It works with snapshots. The target system will be able to automatically create a snapshot each time the replication is done, so multiple recovery points will be available in the case of an emergency. It creates a full volume copy, including the file system. And finally, disaster recovery to another system is much easier. As for the limitations of remote replication, first of all, it requires similar hardware configuration on both sides, for example, interfaces. Next, synchronous mode requires a low enough latency. We're talking about less than 250 milliseconds. And finally, usually needs more capacity and resources compared to Rsync. Now, for the use case scenario of a remote replication function. A financial company operates its primary infrastructure storage system in Singapore and a secondary system in Tokyo. Critical databases and virtual machine data stores are continuously replicated at the block level between the two sites. In case of an unexpected outage at the primary data center, workloads can quickly be restarted on the secondary system with minimal disruptions to business operations. This setup not only ensures business continuity, but also supports regulatory requirements by keeping an up-to-date copy of sensitive information elsewhere. Since replication can be asynchronous, it remains efficient even across long-distance networks, while synchronous replication is available for metropolitan environments where near-zero data loss is required. Finally, the third and most advanced replication option in our portfolio is the high availability, or HA, service. HA provides the smoothest possible experience as well as the highest reliability for both users and production. It involves the creation of a two-system cluster working in either active-active mode for block-level HA or active-passive mode for file-level HA. Additionally, the clustered systems are monitored by a special witness server that automatically decides whether and when failover is needed, eliminating the need for manual switchover in case of a critical site failure. Its advantages include, first of all, maximum fault tolerance. Next, zero RPO, recovery point objective. So in the event of a failure, the organization's data can be recovered up to the very moment of the failure with no loss of data. Next, near zero recovery time objective, RTO. Due to automatic and almost instantaneous service transition between the storage systems, users do not even notice any interruptions in services. And next, transparent for clients, no service interruptions again. And finally, no manual intervention needed for failover process. Its limitations include, first of all, most demanding in terms of hardware compared to previous methods. It requires two identical systems and enough channels to accommodate internal, witness, and host networks. And also, it is dependent on a stable and low latency network. Now for the use case. A large hospital relies on its infrared HA cluster to support medical imaging applications and patient record databases. The cluster runs with two systems in an active standby mode. If the primary system fails due to a hardware issue or plain maintenance, the secondary system immediately takes over, ensuring uninterrupted access to critical data. This seamless failover is invisible to doctors and staff who continue working without delays when viewing MRI scans, updating patient charts, or accessing lab results. For the hospital, HA clustering means 24/7 availability of life-critical systems, minimum risk of downtime, and the confidence that patient care will never be compromised by storage outages. Here on this slide, we've outlined the three main replication methods available in our GS systems, along with some guidance on when to use each of them. First is Rsync. This is the simplest and most cost-effective option. It works at the file level and is ideal for synchronizing data between offices or branch locations. Typical use cases include project files, media content, or periodic backup jobs. It is not real-time, but it is flexible, reliable, and budget-friendly. Next is remote replication. This is a more advanced tool. It works with both block and file level volumes and provides asynchronous data replication across long long distances, even between different countries or even continents. This makes it a strong choice for disaster recovery scenarios where you need your data to be accessible even if an entire site goes down. And finally, high availability cluster. This is the highest level of protection. Two systems or nodes work together, and if one fails, the other immediately takes over. The option is essential for environments where downtime is simply not accessible, like banking, telecom, or online services. We hope that everything mentioned today will be of use to you and will help you to plan out your configurations easier. However, if you require any help or you have any questions, please feel free to contact our representatives online. We are always happy to help.